video, we're going to talk about linear correlation. First, the vocabulary. The line of best fit is a line that fits a set of data points. The center of mass is the point whose coordinates are the means of the x and y values. The correlation coefficient measures the strength of a linear relationship, and the coefficient of determination determines what percent of the data fits the linear model. We continue working with the example from the last problem where we were dealing with diamond weight and the price, and this time it's telling us use the statistics utility to find a line of best fit for the data about the weight in carats and the price of diamond rings from lesson 2.2. So we're going to switch to Desmos. So in Desmos, first thing you're going to do is you want to create a table. So in the table, we're going to enter all of our data, 0.18, 0.17, 0.25, 0.29, 0.27, 0.15, 0.20, 0.25, 0.21, 0.17, 0.35, 0.33, 0.26, 0.16, 0.12, 0.18, 0.15, 0.16, 0.16, and 0.23. We've entered all of our x values, so now we'll enter all of our y values. 702, 517.50, 963, 1290, 1080, 484.50, 747, 1017, 724.50, 529.50, 1629, 1417.50, 994.50, 513, 334.50, 664.50, 430.50, 507, 498, and then 829.50. And take note, we can't see our screen right now, so we're going to try to zoom out some. See if we can start seeing some points. Oh, here we go. So let's hit the wrench and change our screen. So on our x-axis, we don't want to be any smaller than 0. And it looks like our smallest is going to be 0.35, so we'll just say 0.5. And then on our y-axis, our largest looks like it's going to be 1,000 something, so we'll say from 0 to the biggest is 1629, so we'll just say 2,000. And now we have a better view of these points. Our next step is we want to find the equation of the line of best fit. So we're going to say y, and then we'll hit tilde. So that's right next to number 1. Shift tilde, So we have to say y1 underscore 1. There we go. y1 underscore 1 m x underscore 1 plus b. And we can see our our slope and our y-intercept. So in our next line, we're going to say y underscore 1 equals, or we can say y equals 5501.53 x plus, or just minus 372.674. And you can see they're both the same line. So we've answered our part A. It's just y equals 5501.52 x minus 372.67. According to the regression line, how much will a 0.5 carat diamond cost? So now we just have to plug in. So y equals 5501.52 parentheses 0.5 minus 372.67. 0.52 minus 372.67, and that gives me 5128.85. And we're done part B. Part C is asked to verify that center mass 0.12, comma 793.65 is on the line. So what we're going to do is we're going to do that in Desmos and just verify it. Or we can just plug it in here. So 5501.52 parentheses 0.212 minus 372.67, and we're going to get an approximation because we did round. We're not using the utility to verify. And I get 793.65 with a bunch of decimals. So this does approximately equal 793.65, and we're done. Part D, find the correlation coefficient and coefficient of determination and explain what they mean in the context of the problem. So we're going to use Desmos to find that information. We'll pause and switch. So in Desmos, we can see r squared equals 0.9826, and the r value is 0.9912. So let's write that down. We're going to write that down. So r equals 0.9912. This is my correlation coefficient. We'll just write CC. And this says there's a strong linear relationship. And then for our coefficient of determination, I'll write CD. That's my r squared value, and that was 0.9826. And this says 90 98.26% of the data fit the model. And we're done part D. The graphs below show some scatter plots, and we want to determine the strength and direction of the scatter plots. So the first graph, notice how all the dots are really close to the line, so we could say this is a strong and it's positive because the slope's positive. Take note in the next graph, the dots are farther spread apart from the line, so we say this is a weak, but since the line's going up, it's a weak positive correlation. And then the next graph, the dots are just all over the place, so we can just say there's no correlation or zero correlation. In the next graph, we can see that the dots are a little bit spread apart from the line, so we can say this is a negative. This is a weak negative correlation. The last graph, we can see that the dots are really close to the line, so we can say this is a strong negative correlation. And then the last concept we want to make sense of is what the R values tell us. So the closer we are to zero, this means there's no correlation. And as we get far closer to positive one, this is strong. The closer we get to, we move from weak to strong. Let's add the word weak in here. So we go from weak to strong. And this is also your positive correlations. And then we go from weak to strong into the negative direction. And these are your negative correlations. And we are done talking about correlation. Hope this helps you understand.